Hello students, this video is on section 2.4, adding fractions. To add fractions, in order to see how it works, we can use models at first. So an example would be if we had a candy bar and it was cut into 4 equal parts. And if I eat one of those parts, and then I break off another part and give it to you, what do we come up with? So it might not be too difficult to see using this picture here, that 1/4 and 1/4, when I add those two things together, I get 2/4. And that simplifies to 1/2. Makes sense because half of the candy bar would be gone. Okay? When we're adding fractions, we need to make sure that we're talking about the same size pieces. That number comes from the denominator. So I'll show you another one with a diagram. If I have 1/5 of something, and to that 1/5 I add 3/5, 1, 2, 3, how much of the total fraction have we taken all together? The total is 4/5. You can see that here. 1, 2, 3, 4 out of 5 pieces. It's important to know that when we are working with fractions, we're not adding up the denominator. I'm not cutting this into more pieces to have a larger denominator. I'm working with the same size that we started with. Okay? It might hopefully be apparent to you at this point that we don't need the diagrams to solve these properly or quickly. So let's do one without a diagram. If I have 4/9 of something and 1/9 of something, what do I have all together when I add those up? Hopefully you can see the pattern that 1 plus 1 gave us 2. Here, 1 plus 3 gave us 4. And so here we have 4 plus 1 would give us 5. And the pieces are not changing in size, so our denominator stays the same. Okay? So this is the most basic form of adding fractions. When the pieces that we're putting together are made up of the same size, that is to say that their denominator is the same, then we just add the numerators and the denominator stays the same because we're not changing the number of pieces that the thing is cut into. Okay, let's do a few more examples quickly. If I have 5/6 and 1/6, the denominators are the same size, so I add the numerators and I get 6/6, which we will be reducing now that we've done reducing fractions in simplest form. 6/6 is the same as 1. Okay? Another example for you would be 3/14 plus 5/14 plus 8/14. Okay? 3, 5, and 8 all over 14. Since the denominator is the same, we can simply add across the numerators and leave the denominator the same. As we can recall with the pictures, the size of the pieces are not changing, so the denominator does not change. 3 plus 8 is 3 plus 5 is 8. 8 plus 8 is 16. Because the denominator doesn't change, we keep it over 14. but now we need to put this into a mixed number. There is 1, 14, and 16, and then what's left over on the top is 2. But we can even simplify that further because our fraction can be reduced. So our final answer here is 1 and 1 over 7. These both have a 2 in them, so I divide them both by 2. And I end up with 1 and 1/7. Okay? Very good. Okay. We are not always given fractions with the same size denominator. And as you have seen, it's pretty simple when we have them where they have the same denominator, but if they do not have the same denominator, that's going to be a problem for us. So for example, if we have 1/2, and to that 1/2 we add 1/3. We cannot say that this is 2 on top, because what would it be 2 over? We've been keeping the denominators the same, and they're not the same yet, so they can't stay the same at the end. So to see how this would look, here's my 1/2. Here's my 1/3. But since they're not the same size piece, I can't really do much until I make them the same size piece. And the way that I'm going to do that is by cutting the pieces into smaller pieces so that they are the same size piece now. So what I'll do is I'll draw a line here and here. So now these pieces are smaller, so I need to cut these pieces to make them look more the same. Okay, and here I'll do the same thing. Okay, so what I've done is I've created them so that they all have the same size piece. The pieces are smaller now, there's more of them. So here's 1 piece, 2, 3, there's 4, there's 5, and there's 6. This one has 1, 2, 3, 4, 5, and 6 pieces. So 1/2 in terms of sixths is how many? We have 1, 2, 3 that are still shaded. Okay? In terms of sixths, how many thirds are shaded? Excuse me, how many pieces are shaded from 1/3? 1, 2. Okay? When I look now, I have a common denominator, which is necessary. And 3/6 plus 2/6 is 5/6. Okay? Now, hopefully you know from one of the previous sections working with equivalent fractions that we don't need to draw the pictures out like this. What we do need to be able to do is find the least common denominator, which is the least common multiple of the denominators. Okay? So here is another example. 8/15 plus 7/20. So hopefully you have what you need to be able to figure out what the least common denominator will be between 15 and 20. If you don't, what you want to do is find the least common multiple of that. Take your time, work it out, get that done. I happen to know that it's 60. So they're both going to be 60 now. Okay? Now, what I need to ask myself is, how do I get there? How did I take 15 and get 60 from it? I multiplied it by 4. And whatever I do to the denominator, I must do to the numerator as well. So I take the 8 by 4 as well to get 32. These, on top of each other, are equivalent fractions. We can change how something looks without changing its value, and that's what we need to do in this scenario. We're going to do the same thing here. Hopefully you can see that 20 goes into 60 3 times. So we're going to do the same thing with the top. 7 times 3 is 21. And so now we have a new set of fractions that we're adding together, 32 plus 21 over 60. And that becomes 53 over 60. That does not reduce. If it did, we would need to reduce it and put it into the lowest form. But that's the way that we will do numbers without a common denominator. We must get them to be a common denominator before we can put the pieces together, because if the pieces are not the same size, we cannot put them together. Okay? I'll do one more for you. And it is 1/3 plus 5/6 plus 4/9. Okay? So again, we need to find a common denominator. But now we have 3 to deal with. We have 3, 6, and 9. If you aren't able to see what that's going to be right away, do the least common multiple for 3, 6, and 9. But it will be 18. Okay? Okay. So what I need to ask myself now is, what did I multiply 3 by to get to 18? I multiplied 3 by 6. So I must do the same thing to the numerator to keep it as the same value. 1 times 6 is 6. What did I multiply 6 by to have 18 be the result? I multiply it by 3. So I must do the same thing to the top to keep the fraction the same value. 5 times 3 is 15. And finally, 9 into 18 is times 2. And we'll do the same thing here. So 4 times 2 is 8. When I add all of these together, I have 6 plus 15 is 21. 21 plus 8 is 29 over 18. Remember, the size of the piece is not changing, so the denominator won't change. It'll stay the same. But we do need to reduce this. There's 1 18 in 29. And then when I subtract that many pieces away, I'm left with 11 18ths left. Okay? If you have any questions about this video, please write them down and ask during class. Thank you.